Okay, so these are some of the common waveforms. Okay, we have here the square wave. So usually square wave, it passes through filters na sa pagkakaalam ko, ano? Minsan may review. Also have here the triangle wave, the sine wave, and the random noise wave. So basically, as you can see here in these common waveforms, have definition of these images. No? The ratio of the peak-to-peak amplitude to the standard deviation for several common waveforms. For the square wave, this ratio is 2. Okay. For the triangle, it's square root of 2 or 3.46. For sine wave, 2 square root of 2 or 2.83. While random noise naman has no exact peak. Pabago-bago siya. Okay. It's approximately 6 to 8 times the standard deviation. So yeah, we have some figures and images here of the common waveforms and their particular standard deviation values. Okay, so make sure to have this noted. And let us now continue our frequency formula. Ano ba tong frequency formula? Frequency, again, let's study the frequency. Frequency is the total number of occurrences of a repeating event per unit of the given time. So for example, you have here, as you can see sa image na meron tayo, these are what you call wave cycles. No? There are different frequency formulas to calculate frequency depending upon the quantities known. For example, ito ang given, you have frequency, meron kang time, meron kang velocity, velocity, amplitude pala. So depending on what values are given or constant values are given, you can definitely compute for the frequency. Okay, again, frequency is the total number of occurrences of a repeating event per unit of the given time. So these are the formula for the frequency of a wave is used to find the f, frequency, time, period, t, wave speed or v, wavelength, lambda. 1 hertz refers to the 1 cycle per second. So yeah, as you can see here in this image, we have here the wave cycles. No? So dito sa image na to, we have 1 cycle. Kung makikita nyo yung example natin kanina, no? Ito, 1 cycle from A, B, C, D, E. Dito, sa example dito sa atin, is 1 cycle, 2 cycles, 3, 4, 5, 6, 7, and so forth and so on. So 10 hertz, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cycles per second, so 10 hertz. Okay. So every 1 second, you have 10 cycles. Okay. So that's how cycles are being presented here. Meron naman din tayong characteristic ng sound wave. We have the frequency, the wavelength, and the velocity of propagation. Again, the y-axis or the frequency domain here is the given is, for example, amplitude. No? Depende kung ano gagamitin nating frequency domain. But for us, we will be using the y-axis as the frequency domain and the time for the x-axis for time domain. So let us see this frequency formula. So this is the formula for frequency. No? So frequency is equal to 1 over t or time. Okay. F denotes frequency and t stands for time. No? For time it takes to complete one wave cycle measured in seconds. No? So in time we have seconds, we have ano ba? Value ng time, microseconds, seconds, hours, di ba? Years, mga ganyan tayo eh. So from years, convert mo siya into months, months into days, days into hours, hours into seconds. So that's how time is being measured. Okay. But again, for frequency, we use seconds. Okay. The frequency unit is hertz. It's z. It's z. Okay. Which equals 1 over second, 1 cycle per second. Other frequency units include millihertz, megahertz, kilohertz, and so on and so forth. So for example, how to find the frequency of a wave in which 1 cycle is completed in 0.25 seconds. So given the value of seconds, the value of 1, constant value of 1, and the value for the The formula for frequency is direct substitution lang naman din yan. 1 over 0.25 is 4 hertz. 1 over 0.25 or 1/4. 4 times 1 over seconds is 4 hertz. Okay. So here are more examples about frequency. Okay. For example, we have signal that repeats every 0.005 seconds. We want to calculate the frequency of this signal. So frequency is equal to 1 over time. Wala man lang calculator dito, but let us compute. No? 1 divided by 0.005 equals lan 200 hertz, 0.2 hertz. Okay. And for the next example, suppose we have a sound wave with a frequency of 440 hertz. We want to find out the period t time of the sound wave. Again, here's the formula. Time is equals to 1 over frequency. So direct substitution, 1 divided 440, 0.00222222227. Try nyo na rin sa inyong mga computer, sa inyong mga cellphone. So the uh, time travel for the 40 hertz, 440 hertz is 0.227 seconds. Okay. Here are some of other examples. A pendulum completes a once full swing back and forth every 2 seconds. What is the frequency of the pendulum's motion? So again, frequency is equal to 1 over t, 1 over 2. Edi, basic lang yan, 1 divided 2 is 0.5. Yan. And try nyo compute para makita ninyo. Okay? A tuning fork vibrates at a frequency of 512 hertz. What is the period of sound wave produced by the tuning fork? Again, direct substitution lang din naman to. So 1 over 512. 1 over 512 hertz. 0.19, 0.00195 seconds. Okay. So next, a person heart beats 72 times per minute. Okay, naka-minute tayo dito. So you have to convert this minute into seconds. What is the frequency of the heartbeat in hertz? So minute is over 60. 1 divided 60 to. 1 divided 60. Yeah, 72 beats. Yeah. Divide 60 muna. 72 divide 60. 1.2 hertz. Okay. So hindi mo dapat limitin yung 1 minute. You have to make sure that you use seconds always. Okay. So T mo is 72 over 60 is equal to 1.2 hertz. Okay. So a digital clock internal oscillator has a frequency of 32.768 kilohertz. Kilohertz. So you have to convert this kilohertz into hertz. Okay. Again, frequency is the unit is hertz only. It's a frequency. What's the period of the clock signal? So from 32.768 kilohertz, you have to convert it into hertz. So given here in the example, 32.768 kilohertz is equal to 32,768 hertz. So what is the period of the clock signal? For let us use direct substitution again. Zero point zero 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 three seconds. Or you can also convert it into microseconds kung ayaw nyo ng mahabang zeros. Okay, so again, we have to make sure that we use seconds as the basic unit of hertz. Okay, so let's play the remaining videos here so you can grasp the wave period frequency, the amplitude wavelength, and the rest.
Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 104. It's on wave period and frequency. Period is the time between oscillations in a wave, and frequency is going to be how many oscillation or waves do we have per unit time. Now, it's sometimes easy to confuse frequency with the velocity of the wave, and so we're not even going to start with waves. We're just going to start with some flashing lights. And so the light on the left is flashing. Try to figure out the period. How much time is there between each flash? And the right answer is there's 1 second. And so the period, or capital T, is 1 second. There's a flash every 1 second. That's the period. What's the frequency then? Well, we're having the flashes, and so it's how many flashes we have per second. And since we have one flash every second, our frequency is 1 flash per 1 second. Now, the units for that is going to be in hertz. And so our frequency is 1 hertz. Now let's look at the other light. And so it's flashing as well. Try to just figure out what the period is. You can see it's slower. And so the period in this case is going to be 2 seconds. So it's taking twice as long between each of the flashes. So what's going to happen to the frequency? So now we've got one flash per 2 seconds, and so what's going to be the frequency? It's going to be 0.5 hertz. And so period and frequency will always be the reciprocal of each other. Once you know period, 1 divided by period is going to tell you the frequency and vice versa. And so waves transfer energy through oscillations. The wave period is going to be the time between the waves, and then the wave frequency is going to be a wave or a set number of waves per unit time. Now we measure period in seconds, and then we're going to measure wave frequency in hertz, which is the number of waves per unit time. Now, if you're ever looking at a wave diagram like this, the first thing you want to do is figure out what are my axes labeled. And so the position is changing here, but this is over time. Now, you could also have wave diagrams where it's position here and position here. But since we have time on the x-axis, if I want to figure out what the period is, I simply measure the distance between waves. And so I find one wavelength, so one oscillation, and then the distance between the two is going to be the period, or it's going to be the time. If I wanted to figure out the frequency, then it's simply the reciprocal of that. And so let's do a little simulation. This is a PHET simulation. What I'm going to do is generate some waves. And so those waves are moving from left to right. And so this is going to show us the position, but it's going to have a certain frequency and therefore a certain period. Now, a way to see that is to slow it down. Since we're looking at a position of the wave over here, I've also added a clock. And so we can keep track of that time. And so we're going to create one wave. And so I'm going to stop it after we go through one oscillation. And so what's going to be our period? Well, we've got the one wave here, but what's the period? It's the time. It's simply 0.67 seconds. And so that's the time distance between waves. We're just about to start another wave. Now, if I want to figure out frequency using this simulation, what I could do is just let that clock run until it gets to 1 second. So I've stopped it here, so that's 1 second. And so how many waves do you see on the screen? Well, I see 1.5 waves. And so our frequency is going to be 1.5 hertz. Now, we could have done it just by looking at the simulation, doing some experimentation, or we could just do it mathematically. If we want to convert from 0.67 seconds into frequency, all you do is we would take that period that we calculated, 0.67 seconds, we take 1 divided by 0.67 seconds, and we'll get 1.5 hertz. Let's say you're given a problem and you want to solve what the period and the frequency are. The first thing you want to do is look at your axes. And so we got meters here, and then we've got time. And so if I want to figure out the period, remember I just find one wavelength. And so I could say right here is the top of one, and we go back to another top. So this one's at 25 seconds, this one's at 45 seconds. So what's my period going to be? It's going to simply be 20 seconds. If I want to figure out what the frequency is, then what's the easiest way to do that? Well, once I have my period at 20 seconds, I simply take 1 divided by the period, and I'm going to get a frequency of 0.05 hertz. And so did you learn to use a graphical representation of position versus time to calculate the period and the frequency? I hope so, and I hope that was helpful.
In this video, we're going to talk about things associated to waves, like the period, the frequency, the amplitude, the wavelength. So let's say you have a graph, and there's a wave on the graph. This is one cycle of the wave. This is 2 cycles. 3 cycles, and so forth. The time it takes to complete a cycle is known as the period, and the symbol that represents the period is capital T. The distance between cycles is the wavelength, and that could be in units like meters, feet, miles, but meters is the most common unit for wavelength. The amplitude is this portion of the wave. It's 1/2 the distance between the peak and the trough. So this is the peak of the wave, that's the top part, and this is the trough, which is the bottom part of the wave. Now the peak of the wave is also known as the crest. So perhaps you've heard of the expression, the wave crest. That's the top part of the wave. The frequency is the inverse of the period. It's 1/T. Now the period is typically measured in seconds. It could be any unit of time, it could be minutes, hours, but the standard unit of period is the second. And the standard unit for frequency is hertz. So 1 hertz is 1 second to the -1. It's 1/s. Now the speed of the wave is basically the wavelength divided by the period. So you can see this as wavelength times 1/the period, and 1/the period is the frequency. So the velocity of the wave, or the speed of the wave, is the wavelength times the frequency. So these are two important equations that you want to remember. Frequency is 1/the period, and the wavelength times the frequency is equal to the velocity. Now, if you want to calculate the amplitude, and if you know the maximum value and the minimum value, the amplitude is basically just 1/2 of that. It's the max minus the minimum value, which gives it a range, divided by 2. So that's how you can calculate the amplitude of a wave. So now let's work on some problems. Consider the graphs shown below. Determine the period, wavelength, frequency, and amplitude of each wave. So let's start with the period. The period is the time it takes to complete one cycle. You can also calculate it by taking the total time, dividing it by the total number of cycles. So how many cycles do we have in the red wave? Starting from here, this is the first cycle, second cycle, the third one, and this makes the fourth cycle. So in 12 seconds, this wave has undergone 4 cycles. So 12 divided by 4 is 3. That means it takes 3 seconds for this wave to complete one cycle. So this is 3, this is 6, this is 9, and that's 12. So that's the period, the time it takes to complete a single cycle. Now the frequency is 1/the period. So that's 1/3 seconds, which is approximately 0.33 hertz. The frequency is also the reciprocal of this formula. The frequency is the number of cycles divided by the time, or the number of cycles that a wave goes through every second. Now, let's talk about the amplitude. We can't find a wavelength for this particular wave because we just don't have the information. In this particular wave, the red wave, we have time on the x-axis, meters or displacement on the y-axis. When you see units like meters, feet on the y-axis, that means that the wave, it's a displacement wave. You're measuring displacement with time. So we can't find the wavelength for that, but we can find the amplitude. The amplitude is basically this number, 5. Keep in mind, it's the top number minus the bottom number divided by 2. So it's 5 minus -5 divided by 2. So this becomes 5 plus 5, which is 10. 10 over 2 is 5. So in this case, the displacement amplitude is 5 meters. So that's all we could do for the first wave. Now for the second wave, the blue wave, notice that we have meters on the x-axis. That's going to help us to find the wavelength. Now we don't have time or seconds in the x-axis, so we can't find the period or frequency for the blue wave, but we can find the wavelength. So this is 1 cycle, 2 cycles, 3 cycles. So 30 meters divided by 3 cycles, that means that we have 10 meters per cycle. And that's the wavelength, the distance between cycles. So the wavelength in this example is 10 meters. Now we can calculate the amplitude for this wave. I probably should have designed the problem better rather than saying, determine all 4 of these for each wave. Now, on the y-axis, we have voltage. The max voltage is 12, the minimum voltage is 4, and we're going to divide that by 2. 12 minus 4 is 8. 8 divided by 2 is 4. So the amplitude for the blue wave is 4 volts. So now you know how to calculate the period, wavelength, frequency, and amplitude of a wave. Let's move on to this problem. A wave undergoes 1200 cycles in 5 minutes. What is the frequency and period of the wave? We could use this formula to calculate the frequency. The frequency is the number of cycles that occur every second. So if we take the total number of cycles and divide it by the time, we can get the frequency. Now we need the time in seconds, so we need to convert minutes into seconds. And keep in mind, there's 60 seconds in every minute. So multiplying 5 by 60 will give us the time in seconds. 5 times 6 is 30, add a 0, we get 300 seconds. So we have 1200 cycles occurring in 300 seconds. So let's cancel 2 zeros, so it becomes 12 over 3. So there's 4 cycles occurring per second. So this means that the frequency is 4 hertz. It's the number of cycles that the wave goes through per second. Now that we have the frequency, we can calculate the period. So remember, the frequency is 1 over the period. The period is also 1 over the frequency. So 1 over 4 hertz, 1 over 4 is 0.25. So this is going to be 0.25 seconds. So that's how you can calculate the frequency and the period of this particular wave. Now let's move on to number 3. What is the wavelength of a 3 kilohertz sound wave traveling at 343 meters per second? Now if you remember, the wavelength, which is represented by the Greek symbol lambda, wavelength times frequency is equal to the velocity, or in this case, the speed of the wave. We have the speed of the wave, which is 343 meters per second. We know the frequency, it's 3 kilohertz. K means kilo. Kilo is 1,000, so this is 3,000 hertz. Our goal is to calculate the wavelength. So if we divide both sides of the equation by f, we get the wavelength. The wavelength is the speed divided by the frequency. The speed is 343 meters per second. The frequency is 3,000 hertz. Keep in mind, 1 hertz is 1 over seconds. So the unit seconds will cancel, giving us the wavelength in meters. So now let's do the math. So it's going to be 343 divided by 3,000. And so the wavelength is 0.1143 meters. If you multiply that by 100, you can convert that to centimeters. So that's 11.43 centimeters. So that's how you could find the wavelength given the frequency and the speed of the wave. Number 4. A wave has a peak-to-peak length of 25 centimeters and a period of 40 milliseconds. What is the speed of the wave? So let's draw our wave. So this is one cycle of the wave. But if we continue it, now we have a second cycle. You could find a wavelength between these 2 points, or from one peak of the wave to the other peak of the wave. So that peak to peak distance, that's the wavelength. So we have a wavelength of 25 centimeters. Now let's convert centimeters to meters. 1 meter is equivalent to 100 centimeters. So we got to divide by 100. So 25 divided by 100 is 0.25. So the wavelength is 0.25 meters. Now the period is 40 milliseconds. 1 second is equivalent to 1,000 milliseconds. So if we divide 40 by 1,000, we'll get the period in seconds. 40 divided by 1,000 is 0.04. So that's the period, 0.04 seconds. That's the time it takes to go from one peak to another, or the time to complete one cycle. Now the speed of the wave is the wavelength divided by the period. So we have the wavelength, which is 0.25 meters, and the period, which is 0.04 seconds. This will give us 6.25 with the units meters per second. So that's the speed of the wave, 6.25 meters per second. Now what is the frequency? The frequency is 1 divided by the period. The period is 0.04 seconds. So 1 divided by 0.04 is 25. So we have a frequency of 25 hertz, or 25 seconds to the minus 1. So this means that this wave undergoes 25 cycles every second. So that's basically it for this video. Hopefully it gave you a good idea into the concept of a wave and features of a wave, like its speed, frequency, wavelength, and period.
Hey everybody, today we're going to talk about wave frequency, speed, and wavelength. Let's start with frequency. So frequency is the rate at which something occurs. So if we had a quiz every week, we could say our quiz frequency is 1 quiz per week. When we're talking waves, we talk about cycles per second, or waves per second, which means how many wavelengths occur every second. Now a cycle is equal to 1 full wavelength. And a cycle can be measured from a point on one wave to the same point on another wave. And so that means you would measure either from crest to crest, or you could measure from trough to trough, or really anywhere in between, as long as the 2 points that you pick are the same points on each wave. Now we refer to cycles per second in the unit of hertz. So 1 hertz is 1 cycle per second, and that's the number of waves that happen over the number of seconds. So a couple of examples: if I have 1 full wavelength that happens in 1 second, then the frequency of that wave is 1 cycle per second, or 1 hertz. If I have 2 full wavelengths in 1 second, then we would say the frequency of this wave is 2 cycles every second, or 2 hertz. Now I can have partial waves too. It's not always full waves that we get. So if I have 1/2 of a whole wavelength in 1 second, I would say that that has 1/2, or 0.5 cycles per second, or 0.5 hertz. And if I have 1 full wavelength in 2 seconds, it works out to be the same, 0.5 cycles every second, or 0.5 hertz. So taking the number of waves divided by the number of seconds will give you the number of hertz, or cycles per second. So we'll do a couple practice problems. If 3 waves pass by in 3 seconds, what's the wave frequency? And so we take 3 waves divided by 3 seconds, and that gives us 1 cycle every second, or 1 cycle per second, which is 1 hertz. If half of a wave passes by in 2 seconds, what is the wave frequency? So same process, 1/2 of a wave divided by 2 seconds of time
gives us 0.25 or 1/4 cycles per second or zero point 0.25 hertz. Now, what is it that determines the frequency of a wave? For this, we're going to go to the PhET simulation and try some things out. Alrighty, in my simulation, I can adjust a few things. I can adjust the amplitude, I can adjust the frequency. I'm going to leave everything else the same. So in terms of our start, I'm going to set this to a frequency of 1 hertz. That means 1 cycle every second. And when I give this wave a little amplitude, we get our waveform. Now notice what is causing the wave. It is this device over here. Now, does that have an effect on frequency? We need to find out by turning the frequency up. So now I want 3.
So you have already finished viewing the some of the sample formulas and equations with regards to wave period frequency, and at the same time you were able to grasp the idea of the wavelength, how to compute the wavelength, how to compute the speed over time of various frequencies. Okay, so let us now check the frequency bands associated with frequency, of course. So let us check ano ba itong radio spectrum and radio frequency. I think we could study this later on the following weeks na sa ating mga subjects. So let us study signal processing, no? Signal generation, signal modification, and extracting information. Okay, so this is the last slide of our class for today. So basically, signal generation is being generated by human or by computers. For example, pag nagsasalita tayo, kakausap tayo, there is a voice or signal that is being generated. Okay? Over the phone, may nakakausap tayo, nakapag-transmit tayo ng voice or signal. Then dadaan siya into some sort of modifications or modulations for the voice to make this quality its quality improve, no? I-improve natin yung quality ng voice using modulations. Okay? For example, the common voice frequency is 2 hertz. Di ba? Nakita nyo naman kanina yung iba't ibang voice waves and frequencies depending on what kind of activity we are doing. Okay? So when we generate voice, we generate signals. Okay? If we modify our voice through amplitude modulation, tulad ng sinabi natin kanina, is either you compress, either you reduce the noise, you improve the signal to produce a more better signal or better voice. Okay? So for example, nagsalita ako, okay? For example, sa isang cellphone o sa telepono, pag nagsalita ako, makapag-generate ng signal, and pagdaan sa channel, sa telephone wires, or sa towers na nagbabato ng signal, imo-modify niya yon para nang sa ganun, pag na-receive mo yung boses ko, wala nang feedback, wala nang noise. Okay? That's modulation na tinatawag. You are modifying or manipulating the signal that is traveling over time. Ngayon, kapag ka nag-travel na yung voice over that specific channel tinatawag, for example, sa radio, no? Pagdating sa antenna ng radio, pag na-receive niya yon, imo-modify niya yung voice signal into electrical waves, i-extract niya yung information, and then magiging speaker na siya. Doon ka nagkakaroon ng sound waves ang tinatawag or voice signals pagbalik. So that's how you process signals from the time you generated it using your voice, and matatransmit siya over time over a channel through modulation. It's either you improve the quality of the voice or improve the quality of the data being transferred, being transmitted, and received by the radio antenna. Okay, then again, you extract information from that analog signal into digital signal, or baliktad, from digital signal to analog signal, na yun ang nababasa natin o napapakinggan natin. Okay? So that's how signal processing works. Okay? So on our next video, next presentation, I will study more on how technically signals are being processed. But that's the idea of how signals are being processed using generation, modification, and extracting of information. And also, next on our next meeting, let us visit this radio spectrum and radio frequency. Okay, so we have different frequencies from 2 hertz up to 2000 megahertz, gigahertz, and kahit ano pang hertz yan, no? Kapag yun yung ultraviolet rays, no? Meron siyang spectrum and hertz na tinatawag that we have to avoid to make us safe, to keep us safe. No? Pag-aralin natin siya next meeting. So, yeah, I hope that our first meeting is worthwhile. No? Please take note of the following terminologies. No? So frequency, we have the amplitude, the wavelength, the frequency, and the continuous, discrete, and digital signals, its conversions, and the frequency, the function of time with respect to time, y-axis being the frequency domain, and the x-axis as the uh, time domain. Yeah. So the AM modulation using the carrier signal, the information signal, or the voice signal, or the modulated signal, and the common waveforms, the sine wave, square wave, triangle wave, and the noise, the characteristic of cycles, and the formula for frequency. Frequency is equal to 1 over t, where t is equal to time, or t is equal to period of time, should I say. And the unit for frequency is hertz, 1 cycle over second, yeah, by time. Okay. So hopefully, yung mga examples dito, aralin din ninyo. And the videos presented, please take note of this as well. Okay. So yeah, thank you very much for your attention. See you again on our next meeting.